Okay, so what is closed-loop automation? So if you look at the way that we've really embraced, especially as operators, we've embraced this whole idea of automation. I think that we're moving along. While some of the challenges were brought up today, I thought some of the discussions earlier were just outstanding around programmability, automation, orchestration. And I think that we're moving in the right direction. There's some good open source tools specifically to focus on the networking. We talk about Ansible, Python. We'll talk much more about Yang models today. But I think we're moving in the right direction as it applies here on this left side that you see. I'll call it southbound, where we've fallen over, and I see some IETF experts in here that have probably lived this, that I just sat on another panel with. We know that actually getting the data and the telemetry off of the devices has not been as easy. And the first thing you think of is, well, SNMP and syslog, and we're still living in the CLI world. And we talk about how we're moving the actual telemetry off the network elements. It's been hard and complex, and it hasn't been very operational friendly. It's been unstructured, et cetera, right? So one of the things that has transpired over the last couple of years, and we've had a couple topics on that today as well, is this whole idea, this push model, or the idea of streaming telemetry. And the idea of streaming telemetry, and I'll add the model driven into that, it adds another dimension to that, specifically for operators. So we talk about structured data, and we're able to operationalize it. We can actually look at this from an event detection perspective, where we can actually gather the data periodic. One thing I will say, and I know that multiple vendors support this, is that the network elements are much more optimized now for moving this telemetry, off of the routers or off of the switches or, off of the firewalls, et cetera. But we're optimizing more how we actually move the data off. So this concept of streaming telemetry is another huge piece as we get into this. So if I put these together, what you get is this, what I'm referring to as closed loop. And when you put these together, you get this whole slew of use cases that we can leverage, where I'm leveraging the automation, programmability, orchestration southbound. I'm leveraging moving this very, very important vital data. Like, I thought Russ White was talking about how important data was earlier, and we're able to move that from a network operations perspective or a network element perspective off of the devices quicker. I would actually add two other points to this. I talked about optimizing how we move it off of the network elements, one, but two, how valuable the applications are that are sitting northbound here to actually leverage this data, right? We're moving the data off, great, but I got to have the applications to do it. And of course, the business logic, so to speak, and how we leverage that is obviously going to be really where the rubber meets the road on how I manipulate or use the data. But again, that's another piece of this. So if I look at some of the use cases, these are use cases all that I've talked to customers about, or some of them are already leveraging it. The first one is just the configuration validation. That's going to be my demo. Just think of that from a perspective of, hey, I have a configuration and I have dependencies. So for example, I'm not going to be successful bringing up a BGP peer until I have the interface up between the two routers, right? So I got to wait until that comes up. And I'll show you how I go through and leverage some streaming telemetry just to monitor that. Security to me is a really low-hanging fruit here on how we could leverage this. Just think about it. The idea that I'm constantly pulling data, I'm pulling data out of the network elements. It could be, I could search for malware. I can look for anomalies. There's a lot of cool software out there that will actually do this. And then the ability to react quickly. You could say react quickly. It could be as simple as a remote trigger black hole type concept, but obviously with some of the policy models that are out there and some of the things we can do, there's a lot more things we can do in reaction. So think of it as gather, search, and then how do I react to that? It could be automated or it could be operator driven. The QoS is a really interesting one where, think about how we have these KPIs or these key performance indicators, and maybe if I get to a certain level of traffic, whether it be in a buffer depth threshold, for example, I could either move the traffic, I could increase the buffers. There's things that I can do much quicker as it relates to how I automate and program it. And I'll talk about that a little bit as well. We talk about ML, AI, there's a lot of different things we can do with that. And really, this is focused on the day 2+. We talk about, bringing devices up day 0. This is all about, look, the network is running. I'm gathering data now from the network elements. And we're going to talk about the components here and the details. but then I want to leverage that to maybe be a little bit more proactive from an operations perspective. It'd be really cool if I can get state of the router and state of the switch, for example, before it falls over, before it runs out of memory, before the queues start overrunning, right? So the idea that I can, if I'm moving it off quicker and I can do quicker increments, that I can actually react faster as well. So that's the idea and really what I wanted to, kind of set the table. Now let's get into a few of the details here. Specifically the components. So I'm going to break it up into two. I talked about, southbound, the automation programmability. Like I said, there were some great discussions today I really enjoyed. I'm going to dovetail onto those. So first of all, the whole idea of benefit and the benefits of model-driven. And the more I work with this, I talked to some folks, some customers at lunch about this as well. I think this is something that's obviously moving forward. I had a customer tell me that when we look at these variations of Yang models, for example, one of the things that they like to do is say, hey, look, there's these native models that the vendors put out, like a Cisco and a Juniper and Arista, and then you have the open models out of OpenConfig or IETF, for example, MEF. And the idea is that they would like to say, well, look, I want to go open when I can and native when I must, right? Certainly there's more native models than there are open models. But again, that's the concept. And as we look at operationalizing this data, and we're going to talk about these Yang models not only for configuration, but that's going to be what we say we want to stream. When we talk about streaming telemetry, well, what data do I actually truly want to stream? And I'm going to use a Yang model to do that as well, right? So then I get this highly structured capabilities of the Yang models. They're abstracted. They don't know anything about the device. So there's some real key advantages to that. And of course, I've got some open source tools that I can leverage with that as well. This is a model-driven stack that if you just look at the network elements and you say, I have somebody that says, hey, for example, Cisco or Juniper, Arista, I really like your hardware, but you know what? I'm not really into your controller. So I need a way to get the data off that's open, that's standard, et cetera. And I'm going to take care of things myself north of that. And I really like this model-driven stack that we've been leveraging. The idea is that these components are very modular. So for example, I can leverage netconf at XML, with a TCP stack, or, we're sliding, I will say Cisco's sliding a little bit more to leveraging the GNMI model from a Google perspective. So, our support for gRPC and Google protocol buffers and HTTP2 for that transport. As well, and then you can see I have my Yang models obviously at the bottom. This is really, really nice stack just to say, hey, you know what, this is a way that I could start looking at different ways that I can start moving the data, either off the element or to the element. One thing to note here is this model-driven SDK. So what is that? And this is what I talked about last year in my session. So this is an SDK. It stands for a Yang Development Kit. It's an open source toolkit that Cisco, we do contribute a lot to it. And the idea is this. There's an element to YDK where it's YDK Gen. You take the Yang model, and what it does is it produces a set of API bindings in some specific language. And I'm showing you the languages that we support. The one that's the most popular, obviously, is Python, but we also support C++, and we also support Go. We'll continue to look at others, but the idea here is that you're taking that Yang model and you're exposing APIs. So think about it. From a coder or a development perspective, I don't really need to understand the crux of the network or the details of the network. I certainly can understand some of these interfaces and these parameters and these characteristics of the actual feature itself that are in API bindings, for example, in Python. And that's what I'll actually be using today in my demonstration. The other cool thing that YDK does is it adds a transport element to it. We call it the provider piece. And the provider piece here, as I'm showing you, we started off leveraging netconf. So it has that bundled into YDK. And we just started moving towards supporting gRPC as well as a transport as well. So, this gives you this whole idea of this rich validation, one-to-one correspondence with the model. And last but not least, one of the coolest things that it does if you've used this tool at all is that you run the application, say, in a client, the YDK app, and then what it does is it does a local validation check. So if I had something misconfigured, or maybe I used an integer where I should have been using a real number or a decimal, like an IP address, et cetera, what it'll do is it'll catch it, it'll run, think of it as doing an authentication check first before it actually sends it to the device. Again, the validation is done before it's sent to the device, so it's really, really powerful. And the other thing about this is that we can leverage this for southbound as well as, taking off streaming telemetry off the box as well, and I'll show you a few more details of that in a minute. So that's the more southbound piece. There was a really good session this morning about, the time series databases, et cetera. But if you look at, this is something we came up with internally, it's kind of an OSI model of telemetry, right? And most of you are familiar with this, some of you that have used any type of streaming telemetry. If I break it down a little bit further, and what I'm going to look at today is a very, very basic model or basic architecture. And you typically have this collection, storage, and then you have, again, those business logic applications, third party. The storage for what I'm going to demo today is just Kafka. If you wanted to, and that'll be more real time, if you wanted to obviously store the data and come back to it, or run, ML AI against it or parse against it, you obviously could, you've got InfluxDB, you've got Prometheus, you've got all these different types of open source tools that are out there, Grafana to actually view it. One thing I added in here is Pipeline. Pipeline is an open source tool. I think it was created by Cisco, but it is open source. And think of it as a transcoder. So what Pipeline does is in my demo, what I'm doing is I'm streaming the telemetry into a Google Protocol Buffs format, and then what it does is we're translating it into JSON up to Kafka. So you can do transcoding of the data in different formats. You can go, either way you want, and you can transcode it into what you prefer, or maybe what you're going to use you're familiar with from an operations perspective. But very, very helpful with that. Then I throw it up to Kafka, and we'll look at it. It'll be very much in a JSON format. But again, what I did was I took a snapshot for you, for the network folks out there, from one of our configurations. I like how we put the information in one spot. So when you look at the configuration on the network element for streaming telemetry, there's a couple cool things here. So first of all, you've got the where, how, what, and how often, right? First of all, the where is, the IP address of that particular service or that collection device. And that port number is actually Pipeline that I just talked about. The how is, my encoding and protocol, and you have choices there. Here I'm choosing Google Protocol Buffers and TCP protocol, as that transport. And then the how often, if I jump to the bottom, that's every 5 seconds I'm going to stream this. And you'll see it'll pop up every 5 seconds on the Kafka bus as the router pushes the data. The last but not least is that sensor path and the what. And what we're doing there is I'm using two open config models with BGP and the interface. So this is where you define what you want to move off of the router. And what you'll see in the demo is you'll see the interface, because I have interfaces running, so you'll see the data coming up from the interface, but you will not see anything for BGP until I configure it, because it's not configured yet. But again, this is, as an operator, this is where you will select what you are looking to actually push off the box. And we've done some significant testing around performance around this, and believe it or not, like I said, we have optimized this, but there is so much data, as you can imagine, of all the different parameters that you can pull off of here. So it's one of those areas that you definitely have to be careful. Okay, so what I thought I would do in this demo is I just want to show you this is very basic, and I know there's probably some heavy coders in here, so they're probably rolling their eyes a little bit. So this is basic, but it will give you a little idea on the concept of what I'm trying to convey here is how you can leverage like a message bus, and I'm just going to use Kafka, which is more of a pub sub type model. And what we're going to do is I'm going to stream the data, and then I'm going to run just a Python application against it. And I'll go through what I'm trying to do. So we have a couple things here. I have YDK, the Yang development kit that I'm actually doing to configure the device. So I'll configure the interface and I'll configure BGP. And then running in my controller, I'm running this in a lab, and it's all virtual in a lab in San Jose. I have Kafka and Pipeline running each in their own container. So, but we'll be looking at the Kafka bus, and you'll be able to see it. So as you can see, I have ASBR1 here at the bottom and then ASBR2. We'll be looking at ASBR1. All we're going to do is basically load the configuration, And let me go through that right here. I'm going to load the configuration and initialize the configuration. So that's doing that validation check I was telling you with YDK. I have a nice little screenshot. I wish I could take credit for coding this, but another colleague coded this. And then what we're going to do is we're going to configure the interface, and we're going to wait for the interface to come up. And then as soon as the interface come up, what I'm doing here is I'm doing a configuration and I'm waiting, and I'm using that streaming telemetry to look at the state change of the Yang model and specific parameters within the Yang model, and I'll show you what they are. And then after we do the configuration, it'll say okay, and then we're going to start configuring the BGP pair, and we're going to sit there and we're going to wait for the BGP pair until it comes up, and then it'll validate and show that it was validated as well. And the output will be something like this. You'll see it. I'm going to actually move over to my screen here, and I'll show you what I'm talking about. Okay, so let's see. I'm feeling the demo karma here, so let's we've all been there, right? I do have some screenshots, though, as a backup if it doesn't work. But okay, so let's see. I got two things here. What I did was I opened up two windows on my controller. I'll open up a router here as well. So on the right here, let me just start this. This is just consume telemetry Python. All it's doing is it's constantly polling the bus, the Kafka bus. So okay, so that's a really great sign right now for us. So I can at least show you what we're doing here. So let me just take a peek at one little piece here first. The first thing I wanted to look at on the interface is this. So if I go up, I'm doing okay on time here. Let me go up a little bit here. What I wanted to show you the two parameters at the Python code. So there's a validation element to the Python code that's basically saying these are the two fields that I'm looking for that I want to follow and make sure that, and here it is right here. So it's this opera status of the Yang model, and then it's also this admin status. The cool thing about OpenConfig, the OpenConfig Yang models, typically if you look at like for example from a Cisco perspective, our native models, we have a config model and then we have an operational model. OpenConfig includes both the config and operation. So we're going to look at that. So my Python validation code is going to be checking the opera status and the admin status. It's also going to check a field in the BGP model, and I'll show you that after we run this. So let me get cranking on this, and what I'll do is I'll do a time on it. Deploy peers, and then I have my parameters set up just in a little JSON file. So let's run this. So we're just validating. We're doing the validation checks. I'm going to configure the interface. I really wanted to bring up the router. I forgot. Get this out of the way. It's a little small, but. And so what we're going to do here now is it's just basically, it's got the configuration up, so it validated that those interfaces actually changed to up, and I really wanted to get this going too. So I'll let the Kafka bus continue to crank. Bring this back up front, so it's going out there, and you're going to start seeing that on this from a BGP perspective. Okay, there the interface is up. So now in the Kafka bus, I should be looking at telemetry off the BGP peer as well. So let's take a look at that, and let's just see how things have actually changed here. So let me break out of this. So just think, what I want you to do is, forget about the demo for a minute, but just think about I was talking to some folks at lunch and how they just are basically using this type of streaming telemetry just for some basic interface counters. That's all they wanted to look at. They want to look at change state of interface counters, et cetera. Thought it was a really cool, cool way to actually just get your toe, stick your toe in the water on some of this. So for example, from the BGP perspective, one of the biggest fields that I was looking at is, let's see here, was what I was actually monitoring in my validate BGP peer is the session state. So what would it, if we looked at the history of the message bus, it'll show active. So as soon as the peer comes up, it's trying to establish itself, and then it obviously goes established. The other piece that we were looking at on the interface, if you remember, they were down, is we were trying to follow the status there. Let me see, gigabit 00, and obviously you can see here that from an admin status I went to up, and an opera status I went up. So in my code in here, as I was actually running that deploy peers, it was basically running these validation checks. And what's the cool thing about doing the model-driven piece of this is that the data is very structured, right? So when you started looking at how I'm going to parse through this data, and instead of having this gobbledygook of different unstructured text, you can see, you typically, the hierarchical level of a Yang model, it just gives me a very much easier way to go through and parse this particular data for these specific fields that I know I'm looking for, and I know exactly what the parameters are that I want or the state to change on. So that piece of it is really, really helpful. So I know hopefully you guys will have some questions here. So we went through this. If I had a little bit more time, I could show you an error. So typically what I'll do is, and actually one of my customers in here, we took them through this lab, and you can kind of do a failure and run it again. If you fail the other end, and you can see that this would fail. But again, that's really the key piece that I wanted to show you guys today. If you're looking for some basic concepts in the references here, we basically will walk you through. There's some really good data out there to walk you through and how to get started in building your own telemetry stack. One of the things I noticed about the telemetry stack, and even just today, there's a ton of different tools out there, right? So, and even some of the customers that I know, like our SP team is working on, you could talk to 3 customers and they're going about it 3 or 4 different ways, right, using all these different tools. But again, we're starting to get some good data back from some of we'll just call them the hyperscale guys, that really want to do this at a very, very high scale. So, of course, there's a whole compute build out of this as well. Anybody who's interested, drop me a note, and I'll give you some scaling parameters that we did. We did some massive testing with one of our platforms with multiple 100 gigabit links, and we turned on a bunch of parameters from a modeling perspective operationally, and it really wasn't a huge impact, on CPU, for example. It was on some of the compute and some of the storage. But from the network element perspective, because it's optimized now, it wasn't bad. When I say not bad, I'm talking like, in that test, it was less than 10% of impact. So it was pretty relevant. Okay, so just to wrap things up here before Q&A is, I think you guys get where I was talking here. I wanted to give you that concept of what we're doing. I showed you one example of a very, simple model, but this whole power of closed loop, and taking advantage of, I'm taking data, and I have some very intelligent applications, and then how am I reacting to those applications through automation, programmability, orchestration. You choose. You can put different pieces that you want. You may have one specific, streaming telemetry tool you want to use. You may have your own applications, and then you may have other ways. Maybe you don't want to use YDK. Maybe you want to go southbound to the devices a different way. You have a lot of different options here. This is very, very modular on how you can actually leverage this. Obviously, YDK has some key advantages, but I'm sure you have some other tools as well. So with that, one thing I do have here, and this is just more for you guys, and I'll open up for questions. I got 4 minutes, is there's a ton of reference data in here for you. Those of you who are taking notes, my email is crhill. So it's crhill@cisco.com, or drop me a direct message on Twitter, which is on this. I should have put my email on here, and I can give you more data. Those of you looking through the slides, you'll probably see a few more. I typically do that. I didn't have a lot of time, so I was trying to stay in my little 30-minute window here. So there's a lot more slides in your content that I'm showing here today. Okay, so with that, open it up to questions before I turn it over to the next speaker.